Dr. K. Abdul Basith, Professor of CSC, Marri Laxman Institute of Technology and Management. Today, we are going to discuss about iterative statements. So, iterative statements, also known as loop statements or repetitive statements. While you are doing programming, sometimes we need to execute some of the instructions number of times. So this process is called iteration. So iteration can be done using loops. So earlier the iteration can be done using recursion, and iteration can also be done using goto statement. But too much use of goto affects the concept of readability. Readability is one of the language evaluation criteria to evaluate the language. So better use loop statements for iteration instead of goto statement. Another alternative for loop statements, use of recursion. Recursion is the application of stack, which the stack is a data structure which follows the principle of last in first out. So every time the stack has to calculate the address for push operation and calculate the address for performing pop operation. So if you are using iteration, if you are performing using recursion, it is slow process. So better use loops for iteration. So now the real power of computers in their ability to repeat operations, series of operations many times. So this repetition is called looping, one of the basic structured programming concept. So in this, each loop must have an expression that determines the loop is done. If it is not done, so the loop repeats one or more time. If it is done, the loop terminates if the expression becomes false. Coming to the concept of loops, the concept of loop is shown in the flow chart. Here this is the flow chart where you are writing the number of statements and the statements are executed number of times. We certainly do not want this to happen, means we are based on the expression we need to evaluate the loop. So here we must design the loop so that before or after each iteration it checks the task. So earlier if you are not doing checking here, it is fall into infinity. So if not done, the loop repeats one or more times. So if the task is done, the loop terminates. This test is known as loop control expression. Loop control expression. So based on this test expression, the loops are classified into pre-test loops and post-test loops. In case of pre-test loop, so the test expression is evaluated first. If it is true, the body of the loop will be executed. So this process is continuous until the test expression becomes false. Coming to the post-test loop, in a post-test loop, first body of the loop will be executed. After that, it checks the test expression. If the test expression is true, then the body executed again. So this process is repeated until the test expression becomes false. So if you go for pre-test loop, in each iteration, the control expression is tested first. And if it is true, the loop continues, otherwise the loop is terminated. Coming to the post-test loop, so in each iteration, the loop actions are executed, then the control expression is tested. If it is true, a new iteration is started, otherwise the loop is terminated. Now, if you see the flow chart for this, so here you are writing a condition, here you are writing test expression, here you are writing test expression. The text expression first time is true, it executes series of steps. After that, the control goes back to the again condition check. If it is true, again it executes the body. number of times it will be repeated until it becomes false. Once it is false, the control goes to statement X. Statement X is a next executable statement. So coming to the post to test loop, here we are executing body of the loop first. Body of the loop first. Once the body is executed, you are going for condition checking. Here you are checking the test expression. If the expression is true, then control goes to again body. So this is repeated number of times until this test expression become false. Once it is false, so you reach to statement X. Statement X is a next executable general statement in the program. Next, here the true value in the loop expression is referred as non-zero. Non-zero is true and false. Zero is false. Zero is false. So non-zero means either may be a positive value or negative value. Zero only comes under false. Now you can check here the minimum number of iterations required for pre-test loop and post-test loop. First you go for pre-test loop. In a pre-test loop, the test expression first time false. So in a pre-test loop, the body may not be executed if it first time false. Means if first time the test expression falls in pre-test loop, the body will be executed for 0 times. But in case of post to test loop, so this is a post to test loop. In a post to test loop, at least one time the body will be executed. At least one time body will be executed. So even though the first time test expression is false. That is the difference between pre-test and post-test loops. So now coming to the comparison of pre-test and post-test. So pre-test, here initialization with 1 and here also initialization within 1. Here number of tests you are performing n plus 1 tested. So number of tests he required to perform n number of tests in post test loop. So action executed, the body will be executed for n times and here the body also executed for n times. So updation is n times it requires. Here also updation is n times requires. Here minimum iterations it requires 0. Here minimum iteration at least one time it will be execute the loop. That is all about the comparison between two pre-test and post-test loops. So now based on the pre-test and post-test and all possibility and all loop limits, so the summarization of loops into two categories. One is called event control loop, another one is called counter control loop. So coming to the event control loop, it is also known as logically control loop or logical control loop. Logical control loop. So in an event control loop, an event changes the control expression from true to false. So in event control loop, updation process can be explicit or implicit. You can update the you can update the statement implicitly or explicitly. If it is explicit, such a finding a specific piece of information, it is controlled by the loop. If it is implicit, so a temperature of a batch of chemicals reacting to certain point, it is controlled by some external condition. So it is implicit, like one of the example it is. So now that is about event control loop. So event control loop, we can also have pre-test and post-test. So in a pre-test loop, you are having an initialization condition. So then you are checking the condition. If the test expression is true, then you perform series of action. Lastly, you have a updation of the condition. Then you go back to the condition again. Again, it is true. Same process will be repeated until it becomes false. So event control loop also have pre-test loop. Event control loop also have post-test loop. In a post-test event control, so first you initialize the condition. After that, you execute the body of the loop. Then you check for the condition. If it is true, then it executes the body again and again until the condition become false. If the first time it is condition is false, before that one time the body will be executed, at least one time. So another loop statements are counter control loop, where we are maintaining a counter, the counter having a initial value and a final value. Each iteration it is incremented or decremented. When we know the number of times of actions to be performed repeatedly, we use counter control loop. So we must initialize, update and test for the counter. Although we need to know number of times we need to execute the loop, the number does not be a constant. It can also be a variable or a calculated value. The updation can be increment or decrement, in which case we are counting up, or decrement in which case we are down, we are counting down. So here counter control loops also we have pre-test and post-test. In here we are maintaining a counter having a initial value and a final value. So here, based on this pre-test and post-test and event control and event control and counter control, C loops are classified into three types. One is while loop, for loop, do while loop. The first two loops, that is while and for, comes under pre-test loops, and the last one, do while loop, comes under post-test loops. So while is the example for event control pre-test loop, and for is example for counter control pre-test loop, and the do while is the example for event control post-test loop. C does not support counter control post-test loop. So here basically we have the concept of loops. Iteration can be of pre-test, post-test. So in a pre-test, based on the pre-test we have event control, counter control. Here also event control, counter control. So event control pre-test loop example is while. Pre-test counter control loop example is for. Post-test event control example is do while, and C does not support this, not supported post-test counter control loop. Next. So coming to the while loop. The while loop is a pre-test loop where test expression is evaluated first. The while loop uses expression to control the loop. Because it is a pre-test, it tests the expression before every iteration of the loop, and no semicolon is needed after while. So here while expression, so if you write semicolon here, so it is nothing but while with null statement. It is nothing but while with null statement. Okay, better don't use semicolon after while. And here you are writing a single statement. So if it is a single statement, no need to use braces. If it is a compound statement, you must require braces. Here the expression is a valid test expression. So the expression result may be a true or false. True or false. True means non-zero. True means non-zero. False means zero. False means zero. Hope you understand. So now coming to this statement, if it is single statement, you don't need to use braces. It is a compound statement. More number of statements are there, then you enclose these statements in open brace and close brace. Now you can consider this. So first you check the expression. If it is true, then execute statement 1, statement 2 inside the body. So again it goes to test expression. So until it is false, it will execute number of times. Once it is false, you come out of this. So this is where the compound statements is involved. So compound statement, then it must enclosed in open brace and close brace. Here which one is mandatory? So this while is a reserved word in C, and here mandatory is parenthesis. You should not write while without parenthesis, x greater than 0. Without parenthesis, if you write, it is an error. So if you consider a program for finding the reverse the number using while loop. So in this, initialize the variables, declare the variable number reminder and sum initialize with 0. First you enter the number. For example, I am entering the number as 1 2 3 4 is the number. So after reading that number, while number is greater than 0, condition is true or false. It is true. 1 2 3 4 is a greater than 0. So here it enter into the loop. Inside that, the first statement number mod 10. So mod operator gives reminder. So first time the reminder will be 4. First time the remainder will be 4. The sum consisting initially it is 0. 0 into 10 means 0 into anything is 0 plus remainder is 4. So initially the sum value become 4. Next time number is slash by 10. Now we are using slash, then it gives coefficient. So now 1 2 3 4 slash 10 means it gives number as 1 2 3, coefficient as 1 2 3. So then 1 2 3 means again the control goes here. 1 2 3 is greater than 0, condition is true. Again enter. Now you are calculating remainder will be 3. So now sum is equal to, initially the sum having 4, now 4 into 10 40, 40 plus 3 it is become 43. Now the number becomes 12. 12 is also greater than 0. Again condition is true. So 12 greater than 0, true means enter into the body of the loop. Now again you are calculating the remainder. Next time the remainder is 2. So already sum having 43, 43 into 10, 430, 430 plus 2. So 432. Again the if you perform number is number slash 10, coefficient is 1, 1 again greater than 0. So again loop will be repeated for another time. So next again you are calculating the remainder. The remainder is 1 now. Now the sum consisting 432. 432 into 10, 4320. 320 plus remainder is 1. 4321 will be the answer for here. And number slash 10, next time it will give 0, 0 greater than 0. So condition become false. Once it is false, control goes to statement X. In a statement X, you are writing a normal statement. That is, you are printing of sum. Sum if you print, it gives 4321. So reverse of 1 2 3 4 is 4321. Hope you understand this, the use of while loop. So now another loop, that is called do while loop. The do while statement is a logically controlled post-test loop. Like while and for loops, it also used as a expression to control the loop. Do while loop test expression after executing the body. Do while loop is concluded with a semicolon. While should not end with semicolon, but do while should end with a semicolon. The body of the do while loop executed with at least one time. So if you go for a sample and compound statement of do while, so in a simple statement, if you write a single statement, so do and while, these are the two keywords you are using. They are reserved in C. And here the statement is called as a body. Is if you use single statement, no need of any braces. But here the while must end with test expression. The while must end with semicolon. So forgot to write semicolon after do while is a error. So if it is a compound statement, then just do followed by braces. So inside that body will be written inside these braces and remaining is same. So if you go for the same program, for example, if you want to find out sum of individual digits of a number using do while, so here, so same logic we are using, only the sum is equal to sum plus remainder. It only change here. Remaining is same. So you can replace the while with the do, and here while with the number is greater than 0. So here first time it executes, for example, 1 2 3 4 is the number. So initially sum is 0. So now what happens here? If first time you find out remainder, that is 4. So 4 is stored in sum. Again next time 123 is given as a input because 123 is greater than 0. So again it is true, go here, and 123 next time remainder is 3. So 3 already 4 is having in the sum. 3 plus 4 it becomes 7. Next time 2. So 7, 2 is added to 7, it becomes 9. next time 1. So totally the sum becomes 10. Whenever the number is greater than 0, this condition becomes false. It comes out of the loop and it goes to statement X. It executes the sum of individual digits as 10. That is do while. Coming to the first statement. So for is a pre-test counter control loop. So it executes first the for having a syntax like this: for expression 1 semicolon expression 2 semicolon expression 3. So and you write body of the loop after this. So here for is a reserved word. Expression 1, expression 2, expression 3 are valid expressions, and here the 2 semicolons are compulsory, mandatory, we need to write inside the for loop. And for can also be end with semicolon, but generally for end with semicolon means for without body. The meaning of for ending with semicolon is for with null statement. For with null statement. For example, if you write like this, so the meaning of this is like this. And here for loop is used when loop is to be executed known number of times. If you know how many times you repeatedly execute the statements, then use for loop. If you don't know number of times how many times the loop is executed, then better use while or do while. So we can use something while loop, but for loop is easier to read and more natural for counting loops. So for is better than while. So whatever you are implementing using while and do while, you can also implement with the for. The for loop uses 3 expressions. So 3 expression is expression 1, expression 2, expression 3. So all are optional, and the main thing is 2 semicolons we must and should use in for. So now the simple for loop, we are having a flow chart. So a for loop with a single statement, a for loop with more than one statement. So if you go for syntax of this, expression 1 you are using for initialization, and expression 2 for condition checking, and expression 3 for increment or decrement. So first it executes initialization, then it go for condition checking. If it is true, then it executes the body. After that, go to expression 3, increment for decrement. Again it goes to expression 2, again execute it is true, again execute the body, again go to expression 3. This process is repeated until this test expression becomes false. If it is false, it comes out of the loop. So now program to print multiplication table using for loop. So here you are entering the number. So this is initialization part, and you know this will be executed for 10 times, and each time you are incrementing j value by 1. So first time I value is 1, j value is 1. So 1 is less than or equal to 10, condition is true. So it will print 1. For n value is 5, you can take 5 into 1 is equal to 5. It will print 5 into 2, 10, 5 into 3, 15, and so on. You can write 5 into 10, 50. After printing this, the j value becomes 11. 11 less than or equal to 10, condition becomes false. So then you can print the multiplication table. Here the for consisting 3 expressions. All these 3 expressions are optional whenever. So you can use the for loop like this also. For 2 semicolons like this, it is a example for infinity loop. So we can also use like this, and you can also use for loop like this. For int I is equal to 10, I less than 20 without third expression, it is also accepted, and without first expression for only I less than 10, and without this third expression also you can use for also use for I is equal to 0, j is equal to 1, and I less than 10, I plus plus comma j plus plus. More than one loop variable also parallelly you can use inside the for. Use of comma operator, you can do this. It is also accepted in for. Okay, and here only the mandatory is 2 semicolons inside the for. Remaining all expressions are optional, and for must enclosed in parenthesis. This is all about for loop. So we can compare for loop and while loop. In a while, initialization is taken explicitly, but in a for, it can be represented as expression 1. So the condition checking in the while loop, we are representing as expression 2. And here updation part in a while loop can be represented in expression 3 in for loop. Means whatever the program you are writing with while, you can also implement using for. So for example, if I want to write a reverse the number logic using while, so while n is greater than 0, so you can calculate a reminder, n is r is equal to n mod 10, sum is equal to sum into 10 plus r, n is equal to n slash 10. So this is the logic with the while loop. Same thing if you write using do while. So body is same, body is same, body is same. Here you write do, same you copy, n is r is equal to n mod 10, and sum is equal to sum into 10 plus r, and n is equal to n slash 10. Here you write this condition is right here while, okay, n greater than 0. Here semicolon must and should required. Same story you can also using for. So for you can write like this, for n greater than 0. You can write the for statement like this. Inside you calculate r is equal to n mod 10. Okay, sum is equal to sum into 10 plus r, and again n is equal to n slash 10. Only second expression you are writing. You are not writing for the first expression, third expression. So same logic you are implementing with while, do while, and for. Hope you understand. Next, the comma operation. Comma expression we are frequently used in for loop, which is used for representing for with more than one loop variable. A comma expression is a complex expression made of two expressions separated by comma. It is more oftenly used in for statement. The expressions are evaluated from left to right. The value and type of the expression, the value type of it's the right expression. The comma expression has lowest priority of all expressions. So it is like example for I is equal to 0, comma, j is equal to 1, comma, semicolon, I less than n, semicolon, I plus plus, comma, j plus plus. Here in this loop, we are using comma operator in a expression separation. So while you are using iterative statements, we are using three types of control statements. One is break, continue, and go to. So break is a statement which is used for terminate from the loop, which causes termination from the loop. If you are in a series of nested loops, break terminates only in the inner loop, the one we are currently in. So break statement needs semicolon. The break statement can be used in any of the loops, while, do while, and for. The selection of statement like switch statement also we are using break. So good structured programming limits the usage of break statement. So for example, if you go for the while condition, so in a while loop you are using for, inside the for you are writing some statement and you are using break here. So what happens when you use break? So it comes out of the break statement, takes out of the inner loop. So that is from the for loop, the while loop is still active. So if you consider the for with this if condition break, so this is a bad loop style. So better is use a condition here without use of break. Means we can write a code with the break using reverse logic. We can also write the same code with without break. So better avoid use of break. So now coming to the continue statement, so it does not terminate from the loop but simply transfer the control to the next expression in while and do while statement, transfer updating expression in case of first statement. So here it is updating for expression 3. So now here in while loop, so when the continuous comes, control directly goes, the remaining part here will not be executed. In a do while also, so when the continue comes, the control goes to next test expression, remaining part here, this one is not executed, skipped. So although the transfer of different position of pre-test post-test loops both logically think as a jump to the end of the loop body, the user of continue considered as unstructured programming. It is also same. So break statement, by using break statement, we terminate the smallest enclosing loop. So any loop you can take. Continue statement, by using continue statement, so the loop statement is skipped and the next iteration take place instead of the one prior. So the go to statement, C supports go to statement, and this is go to statement is also known as unconditional jump. So go to statement highly discouraged in programming because which affects readability. Readability is the one language evaluation criteria. The language evaluation criteria so influences the language evaluation criteria having certain characteristics. One is called readability, another one is writability, and third one is reliability, and the fourth one is cost. And if you use go to statement which causes readability problem, so any program that uses go to can rewritten, so we don't need to use go to again. The syntax of go to statement is just to go to label, and here label must be followed by colon, and the label can be any valid identifier. So we have two types of go to, forward go to and backward go to. They referred as forward jump and backward jump. So go to label means it jumps to that label and this part is skipped without any condition. Hope you understand. Then it follows the statement. So this portion of the statements are skipped. So forward jump. In backward jump, here, so every time it executes these statements, every time it goes like this. So this is infinity times it will execute if you are not writing under any condition. So while you are using backward jump or backward go to, you must write a condition. Under the condition only the go to statement you can write. Otherwise, if you not write if statement, if you not write if statement, they fall into infinity loop. So be careful with the go to statement. So this is whatever the program you are implementing with the loops, you can also implement with the go to statement. For example, so same if you go for printing of sum of n natural numbers, so if you write using while, so I is equal to 1 while I less than or equal to 10, so sum is equal to sum plus I, you write like this. So all 10 natural numbers it will count 1 to 10. So same thing you can also implement using go to, which is using like this, I is equal to 1 and you write sum is equal to sum plus I, and here you write I plus plus, here you write I plus plus, and here if I less than or equal to 10, then you write go to statement, go to xy. Xy is what? Xy is label. So label you mention like this. Every time the control goes here. So until this condition become false. Once it is false, the statement is not executed. Control goes to statement X where you are printing so sum, percentage D sum. So whatever you are implementing with loops, you can also implement with the go to statement. So finally, if you go for iteration, so in programming we need to use iteration iterative statements. So iteration can be done in three ways. So three ways we can perform iteration. One is using loops, another one is using recursion, third one is using goto statement. So use of goto affects readability. So that's why better avoid goto statement. And use of recursion very slow, and loops faster than recursion. So better use loops. So disadvantages of goto also mentioned. The goto statements highly discouraged. It makes program logic very complex. The goto makes tracing the flow of program is very difficult. Use of goto makes task analyzing, verifying the correctness of the program. It is very difficult to process. The use of goto simply avoided by using break continue statements. So these are the references we follow. Concept of Programming Languages by Robert W. Sebesta, and The Computing Fundamentals of C Programming, a second edition by E. Balaguruswamy. Thank you for this.